Ahoy, welcome along. It's a brand new episode of the Fun Kids Science Weekly. My name is Dan. Thank you for listening. Thank you for being a part of the mission to learn about all the secrets that are lurking around the universe. This week, we'll learn about a snake that steals its poison. Also, I've got a simple solution to help climate change, and we'll have your questions on stitches, shocks, and seas. That's coming up. First, let's get a lesson from the smartest school outside of the solar system. This is Deep Space High.
Deep Space High, space for all.
Jump into your wormhole and travel to Deep Space High, the school in space. But hurry, because lessons are about to begin.
All right, settle down. It's time to have another look at all the different space jobs that there are and where you lot might fit in.
I still haven't got a clue. I just think maybe I should stick to watching space shows on TV.
Well, we'll see. Who else would like to tell us about a hobby they have or a lesson they enjoy? And we can see how you could contribute to space exploration. All right, Z, you put your tentacle up first.
Well, my favourite lesson is art. I love drawing and designing. I like imagining all the planets we haven't yet visited and what new spacecraft might look like, and just being creative, using my imagination.
Excellent. Art and design require imagination, and no one would have gone into space at all without imagining what it might be like.
But drawing spaceships, it's not really the same as travelling in one.
But it's still important. Come on, I'll show you. Computer, simulation of the International Space Station, please. Welcome to the ISS that orbits around 250 miles above Earth. Budge up, Quark. We're trying not to get in the way.
It is a bit crowded, even for a sim.
That's right. Take a look around. See how much equipment there is. It's not just computers and spacesuits. There's all the equipment to make everyday life as comfortable as possible.
Looks like those astronauts are having lunch. Their plates and cutlery look very high-tech.
Every single thing you see up here has been designed by someone, using their imagination to make each thing as efficient as possible in terms of the space they take up, how they fit alongside other things, and crucially, how much they weigh.
Who cares how much things weigh? It's space, and, you know, it's weightless.
Maybe this'll help. Computer, let's have a sim of the launch of SpaceX's Crew Dragon spacecraft.
3, 2, 1, we have liftoff.
Everything has to come here from Earth, and because of gravity, huge amounts of fuel is needed to lift the spacecraft from the ground. The greater the weight of the equipment, the greater the amount of fuel that's needed. Creative design not only helps make spacecraft lighter, they also help make them more aerodynamic.
The G-force is incredible. It's pushing me down into the seat.
Well done, Sam. You just spotted another design feature. G-forces can be uncomfortable. Well, on your bum. And everyone is affected differently, because just like you lot, astronauts come in all shapes and sizes. Over 50 years ago, NASA developed a material that could mould the astronaut's shape and then return to its rest state when not in use. Hence the term memory foam.
I've got that on my bed back on Earth. It's super squishy, but doesn't sag.
And I bet you didn't realise you had a bit of space history in your bedroom. So as you can see, creative people like designers make a real difference to spaceflight and life in space, as well as helping inspire us all. I can't hear myself think. Computer, end simulation. Space exploration isn't just for rocket scientists and astrophysicists. Even though they are important, being creative is a great way to solve problems, wherever they may be.
Well, I'm hopeless at art and design, but I see what you mean.
Stick with it, Sam. Plenty more topics to get stuck into. Next time I'll be asking some more of you about your hobbies and interests. You may be very surprised at how they fit into space exploration. Not as surprised as I'll be if you ever leave the room quietly. Class dismissed.
Deep Space High, space for all. With support from the UK Space Agency. Find out more at funkidslive.com/space.
Now, you know, if you've got a question, you can always leave it for us, and I will do all the digging for you. I'll turn into a science superhero trying to find the answer. All you need to do, leave it as a review on Apple Podcasts. Find the Fun Kids Science Weekly. There's a little comment box. Drop it there, and I'll see it and I'll say hello. Gabrielle has done that. She is 11 years old. She's from Ireland. She wants to know what happens when you get a stitch. Now, we don't really know. Not definitely. There's a few ideas. You know what a stitch is, though? It's when you're running about and you get that kind of jarring, stabbing pain in your side. Now, there are two ideas that scientists have. One is that the muscle that's between your stomach and your lungs, it keeps the two of them apart, it's called the diaphragm, that it gets achy. It gets achy and a bit weak because all the blood that normally goes there is going to your arms and your legs because you're running all over the place. So that's one idea. The other is that your belly is finding it hard to break down and digest food and drink because you're not letting it rest while you exercise. So I can't absolutely answer that one for you, Gabrielle, but there's a couple of ideas for you. This one is from Ella, who is in Ireland. She's just turned 11. Happy birthday, Ella. She says, what happens when electricity shocks you? Well, electricity is an energy. It's made of electrons that flow, and they're always flowing. They're always travelling. Now, they normally go in a big cycle that finishes at the Earth. Think what happens when you turn on your telly. The energy, it comes from the Earth, through your plug, along the cables, into the TV, goes in a big circuit around the telly, back through the cable, and then down into the Earth. Now, when you get in the way of that cycle, or you touch a bit of metal that's getting in the way, the electrons think it's quicker to go through you to get back home to the Earth than carry on their journey. So it takes a quick little detour through you. And it hurts. The reason it hurts is because electricity has a huge amount of energy in there, and it surges through you, and it's extremely painful. That's why you need to be careful. And that's what happens when electricity shocks you. Ella, thanks for the question. Lastly, this is from Oscar, who is 7 years old, who wants to know, why is the ocean blue? Now, we know that light is made of all colours of the spectrum. We've spoken about this before. Think of all the colours, pretty much they're all in one single beam of white light. Now, the ocean is blue because the particles in water absorb the red part of the light spectrum. So all of the reddy colours, they're gone, which just leaves the blue one left. It reflects them back, which is why the ocean looks blue. If you've got a science question that you want answered on this show next week, you need to leave it as a review for me over on Apple Podcasts. It's the Fun Kids Science Weekly. Now, scientists have discovered a brilliant way to get rid of the plastic problem that the Earth has got. They found something to eat it. Amy Griffin is from Diamond, who have sorted this all out. Amy, thanks for joining us.
No problem at all. Happy to be here.
Now, I think just tell us what Diamond is and what happens at the Diamond Centre.
Absolutely. So Diamond Light Source is a synchrotron. So we actually produce really bright light. It's actually 10 billion times brighter than the sun, so pretty bright. And we use that light to look at samples in a great deal of detail and run experiments. So basically, we do research, scientists bring their samples to us, and we help them to do their experiments.
What are you helping them with, though? What do scientists use the synchrotron for?
So a synchrotron, if you haven't heard of us before or heard of a synchrotron, it's a huge particle accelerator. So it's a great big ring. Our building, it looks like a big shiny silver donut that particles whiz around and around and around it. And there are a few different types of synchrotron. You may have heard of CERN in Switzerland. That's the Large Hadron Collider. And they actually smash particles together to see what happens. But we do something a bit different at Diamond. We speed up our particles until they give off this really super bright radiation, this synchrotron light. And we use that light to look at samples. So some of this light is made up of X-rays. So that means that we can actually see inside samples. So you can basically think of Diamond like a cross between a super-powered microscope, so we can look at things at a really, really small scale, and a cross between a gigantic X-ray machine. So just like if you break your arm, you go to hospital and they look inside your arm using an X-ray machine. Our big machine at Diamond is basically like that X-ray machine. We can look inside things.
Now, how does this link with a way that we can get rid and eat plastic.
So, this is one of the pieces of research that has actually happened at Diamond, and it's all about recycling PET plastic. So, PET plastic is the kind of plastic that makes up bottles that you might drink water out of, or your fizzy drinks. And this plastic actually takes hundreds of years to break down. And even then, it doesn't break down completely fully. And in 2016, some researchers found an enzyme at a recycling centre in Japan that actually eats PET plastic. Now, an enzyme is a small molecule that can speed up chemical reactions and processes. And this enzyme actually could break down the plastic fully, all the way into its ingredients. So it's like if you were baking a cake with all your ingredients, it's like being able to reverse bake that cake so you can actually get all of the ingredients back out of it, ready to make another cake. So really great enzyme, but the only problem was this enzyme that's actually been called PETase took a really, really, really long time to break down this plastic. So we're talking hundreds of years, and that wasn't really that useful to us. So that's where Diamond comes in. We actually help the scientists that were working on this enzyme from the University of Portsmouth to look at this enzyme in a lot of detail. So using our X-rays to look at that molecule and to see exactly how it worked. And they realized that they could tweak it and improve it to make it much, much faster at breaking down this plastic. So now this PETase and enzyme can actually break down this plastic in only a few days. So that is really, really fantastic. And it's going to have a huge positive impact on the problem of recycling and getting rid of plastics in our world today.
What does it do with the stuff when it's broken them down, Amy? So you used the cake image. We can break it down. So we've got the flour, so we've got the eggs, so we've got the milk, a little bit of water, maybe some syrup in there. When the enzyme's doing this with plastics, what's happening with how the plastic was made? What happens to the stuff that it broke up?
So the enzyme has what we call like a little set of snippers, a little pair of scissors in it that can break down all of the really long plastic molecules when it's in contact with it. And this breaks down these molecules into the smaller ingredients, which actually means that all those ingredients can then go back into making more plastic without any extra ingredients needed to make that plastic. Because usually when we recycle things now, they get broken down, but they don't get broken down fully into all of their individual ingredients. So what we call a high-grade plastic can only be recycled into a lower-grade plastic. So, and there's only so many times that we can recycle that same piece of plastic until there's nothing more we can do with it, and it just sort of sticks around for a long time. So the really crucial thing and the great thing about the PETase enzyme is that we can remake the same grade of plastic many, many, many times, which is great.
You said that now you've helped them do this really, really quickly. There's so much plastic all around the world. How useful? How can you help every country with the plastic problem? How can you help, Japan break up plastics back to the molecules? How can you make countries in South America? How transferable is it?
So it's really fantastic, all the work that goes on at Diamond, because it's really a global effort. We do work in great teams with lots of people from all around the world, lots of scientists. So discoveries like this get shared all around the world. So it won't just be helping people here in the UK. It'll actually be helping people all over the world deal with their plastic problems.
Amazing. Amy, thank you so much for coming on from Diamond to tell us all about the plastic eating enzyme. Thank you for being there.
No problem at all.
Now, this week's Dangerous Dan is a toxic snake. We've had many on the show before, but this one is special. It's special because it's a thief, because it steals its own poison, and it knows about it. You'll find the tiger keelback. It's a snake in Japan, in Asia. It's green, like a lime green with black and orange crosses and spots all down its back. It's got a white belly, and it's not that big. It's about a metre, maybe even less, which means it's great prey for a swooping eagle. But they need to be prepared. Because the thing is, this snake, the tiger keelback, it has a brilliant defence mechanism. It eats toxic toads. It eats these toxic toads and it steals their poison. It steals their toxicity. It stores their toxins in the back of its neck. And then if the snake gets bitten, it arches itself, it lifts its neck high into the sky, and it sprays the venomous poison that it has stolen straight at the predator, forcing them to flee. It hurts them, it burns, they fly away, leaving the Japanese tiger keelback to go searching for more toads to defend themselves with. We're travelling back through time now to the age of the dinosaurs.
Age of the Dinosaur with Dinosaur Action Magazine, the #1 mag for dino fans.
Welcome to the Jurassic period, which existed between 145 and 200 million years ago. With the supercontinent Pangaea continuing to separate, more and more big watery lagoons were forming, and along with the new oceans were teeming with life, from the tiny to the monstrous.
Wow, so many animals. But where are the dinosaurs?
Dinosaurs didn't live in the sea, but all of the first creatures to appear on Earth did. On the seabed, you would see sponges that looked like squishy lumps, tiny corals that were building huge rocky reefs and starfish. These animals had been around for millions of years before dinosaurs, and are just like those you'd find on the beach today.
Hey, look at that huge shellfish with wavy tentacles. Cool.
That's an ammonite. It's a close relative of squid and octopuses, whose ancestors had already been around for 150 million years before the first dinosaurs appeared. They came in all sizes. Some were as big as 2 meters wide. The hard shell protected its squishy body, and its tentacles were used for swimming and catching food.
Quick, get out of the way. Something big's coming.
Make way for a plesiosaur, one of the Jurassic period's biggest beasts. Plesiosaurs were sea creatures with tubby bodies, 4 flippers, and a short tail. Some had long, slender necks and small heads, while others had huge heads but short, powerful necks. They were both agile and terrifying. Some of the biggest, like Lioplorodon, were at least 10 meters long. That's nearly as long as a bus. They had sharp teeth that could be over 30 centimeters long. They were the top predators in the ocean, feeding on whatever marine reptiles and fish they could grab.
Let's get out of here.
Away from the oceans in the watery lagoons lived even more sea monsters. Fast fish eaters like the ichthyosaurs were dolphin-like creatures with a tail fin and 4 flippers. Temnodontosaurus was a massive ichthyosaur, over 10 meters long, with huge eyes that helped him see in the gloomy water. Since ichthyosaurs didn't have gills, they couldn't breathe underwater and had to come to the surface to breathe, just like whales do today.
Paleontology. Pick.
Fossilized skeletons don't just tell paleontologists what creatures looked like. They can tell us a lot more. For example, from fossils of pregnant ichthyosaurs, we know that they gave birth to live young in the sea. No fossils of pregnant plesiosaurs have ever been found, but we know their ancestors laid eggs, so they probably came out on land to make nests, a bit like turtles.
Age of the Dinosaur with Dinosaur Action Magazine, the #1 mag for dino fans.
Let's have this week's Science in the News. North America experienced its warmest June month on record, and it's only getting hotter. It's the 4th hottest June ever across the planet. Experts say that this terrifying rise in extreme temperature is a sign that there is a climate crisis that we need to pay attention to. Also, the population of a rare antelope has more than doubled in the last year. The saiga which is an antelope from Kazakhstan. It was on the brink of being extinct, but following some smart conservation, numbers have risen from 300,000 to over 800,000 in just a couple of years. And finally, experts say planting trees across Europe could help climate change. It would make it rain during the summer a lot more, which could help the dry lands that hot temperatures are making. They're dry, they're arid, they could use the water from the trees. Now, the UK Prime Minister, Boris Johnson, has said that he wants to plant 30 million trees every year. I mean, not by himself. That would probably take all year. He's going to get smart people to do it as well. Don't worry about that. And that is it for this week's Fun Kids Science Weekly. Thank you so much for listening. Hey, have you got your tickets yet for the Fun Kids Science Weekly Live? You can come and see us at the end of August in London, putting on a big live podcast show. We'll search out some secrets from the universe. We'll have experiments. We might even have special guests as well. You can get your tickets for Fun Kids Science Weekly Live. It's in London at the Underbelly Festival right now at funkidslive.com. While you're on the website, it's one of the best places, by the way, that you can hear loads of podcasts that we make. You can get them on the free Fun Kids app too. They're on Google, Apple, Spotify, wherever you get your shows from. And Fun Kids, we're a children's radio station from the UK. Listen to us all over the country on your DAB digital radio, on that free Fun Kids app, and at funkidslive.com.
Return to the Monsters, Inc. universe in the Disney Plus brand new series, Monsters at Work. It's laughter thereafter as we meet a brand new cast of monsters voiced by incredible stars such as Mindy Kaling, Henry Winkler, and of course, Ben Feldman as Tyler, a recently graduated scarer who quickly learns the only thing horrifying at Monsters, Inc. is how hilarious it is to be part of the team. Billy Crystal and John Goodman are back in their beloved roles as Mike and Sully. Monsters at Work. Original series now streaming, only on Disney Plus.